guys, these are the notes for 10.5 volume. So all the formulas are in the notes. I'm just going to have a look at the first problem here. First problem is, so you probably want to have a look at the notes as you're looking at this video. You're about to begin work on a swimming pool in your yard. First step is to have a hole dug that is 90 feet by 60 feet by 6 feet deep. You'll use a truck that can carry 10 cubic yards of dirt and charges $12 per load. How much will it cost you to have all the dirt hauled away? So, that's going to be the size of the pool. However, if you read through the problem, it says that there's going to be a truck to carry away the dirt, and the truck can take 10 cubic yards of dirt per load, and it's $12 per load. So, so notice how this is feet. I think it would make more sense to convert this to yards. There's 3 feet in a yard, so 90 feet. 30 yards, 60 feet, that's 20 yards, and 6 feet is 2 yards. That way we can just have our answer for the size of the pool in cubic yards, and then the truck will be taking loads of 10 cubic yards per load. So rectangular prism is easy. The volume is just length times width times height. So for this one, the volume in cubic yards will be 30 times 20 times 2. And yes, use a calculator as needed. 3 times 2 is 6, so that'll be 600 times 2. So 1200 cubic yards. And the volume is a measurement of how much space is inside of something. It's a 3-dimensional measurement. How much space is inside, how much of a certain, liquid, gas, or solid fits inside of something, right? That'd be volume. So we have 1200 cubic yards. The truck can take 10 cubic yards per load, so that'll be how many loads will simply be 1200 divided by 10. That's 120 loads. And actually, I guess I shouldn't have boxed these, because the final question is how much? How much will it cost to have all the dirt removed? Well, the price is $12 a load. So at $12 a load, total cost for haul away is going to be those 120 loads times $12, which is going to be 12 times 12 is 144. Add a 0. $1,440 to have that hauled away. The next problem in the notes is really simple. It says there's a cube. Try to draw a cube here. There's a cube whose edge lengths are 6 feet. So remember, a cube implies that it's all squares. All the faces are squares. And if each edge length is 6 feet, right, the volume is simply 6 times 6 times 6, or 6 to the 3rd power if you like. 6 times 6 is 36, and then 36 times 6, I believe that's 216, but we're using a calculator, yeah. So this is, again, practice 2, comes out to 216, oh, I messed up, kind of. It says calculate the measurement in cubic yards. So what I just did is calculate in cubic feet. So what you'll find here is you could convert this to cubic yards. You have to divide by 27, I believe. But But since we didn't do that, we could do this too. We could change these to yards. These 6 feet is actually 2 yards, as we saw in the previous problem. So if we would have just converted it to yards, 2 times 2 times 2, we would get 8 cubic yards. Again, the problem was supposed to be, the answer was supposed to be given in cubic yards, not cubic feet. I believe here if we divide by 27, which is 3 times 3 times 3, we could get the volume here in cubic yards. 216 divided by 27 is, whoops, 216. Yeah, it's 8. So if you have cubic feet, if you divide by 27, again, it's cubic, so it's 3-dimensional. So here, since we were supposed to divide by 3, a lot of 3's here. 3 times 3 times 3 would be 27. So again, if you take your cubic feet and divide by 27, you can make cubic yards, but you could also make these measurements into yards from the get-go. There's that. If you read example 3, it's actually talking about this building here. The Transamerica Towers, 3,678 windows, take cleaners 1 month to wash. Its foundation is sunk 15.5 meters, which is 52 feet into the ground, and is designed to move with earth tremors. So anyhow, the problem in example 3 is talking about this cone here, or actually this pyramid here on top of the tower. So that's what we're going to be taking a look at. Sorry guys, I kind of messed up here. So anyhow, you have your pyramid. I tried to draw a pyramid here. The height of the pyramid would be from the apex straight down to the center of the base. The base is a square, and it's 52-meter edges. The square has 52-meter edges. And then your formula for finding area for a pyramid is B is the area of the base, so in this case the area of this square, times the height, divide by 3. So your volume will be, again, area of the base, so 52 times 52, times the height of the pyramid, which in the problem was actually given at 256 meters, and then divide by 3. So use a calculator. So the volume here is 230,741.3 cubic meters. Again, that is volume. So the problem here in practice 3 is another pyramid. It says the pyramid is 4 feet tall, and it says the base edge is 6 feet. It says it has a square base, so again, calculate the volume. The volume is the area of the base, so the area of the base is, well, it's a square, so 6 times 6 times the height, which is 4 feet, then divide by 3. Now, since it's all multiplying and dividing, you actually could divide first if you want. 6 divided by 3 is 2, and then 2 times 6 is 12, and 12 times 4 is 48, and that's cubic feet again. Remember, we're doing volume. It's a 3-dimensional measurement, so it is cubic. So we have a cylinder, for example, 4A. So the cylinder is, let's see, the cylinder is 9 yards tall, it says, and the diameter here is 20 yards the diameter, and the formula for volume of a cylinder is pi times the radius squared times the height, pi r squared h, pi radius squared times the height. So in this one the volume is pi times the diameter is 20, the radius is 10, pi height is 9. So 10 squared is 100 times 9, that's 900 pi cubic yards. And then 900 times pi, well, we can just calculate that real quick. 2,827.4. cubic yards. So remember, answer in terms of pi, and then, decimal answer. So B is a cone. Cone is a very similar volume formula to a cylinder. So the cone in this example, example B here, the height is 10 meters, and the radius here is 7 meters. So your volume for a cone is very similar to a cylinder here. It's pi times the radius squared times the height. You just got to divide by 3. So it's the exact same formula as a cone. As a cylinder, it's just that you need to divide by 3. Again, you see your cylinder formula, pi r squared h, and your cone formula for volume, pi r squared h divided by 3. So this cone here, pi times radius squared, so 7 squared times the height, which is 10. Then we'll have to divide by 3. 7 squared is 49. 49 times 10 is 490. So we'll have 490 pi divided by 3. 490 divided by 3 is 163.3. So we have 163.3 pi meters cubed, cubic meters, and multiply by pi to get this decimal answer, 513.1 cubic meters. So in problems practice 4 and 5, A has a cylinder with diameter 8 inches. If the diameter is 8 inches, the radius is 4 inches, and the height is 6, so pi radius squared times height. So 16 times 6 is 96, and so that's 96 pi cubic inches, which is about 301.6 cubic inches. In B, we have a cone with radius 4 inches and height 6 inches. So pi times the radius squared times the height divided by 3. In fact, it has the same radius and height as the cylinder. In problem A, it's just a cone, so we need to divide by 3. So it's really just going to be these same numbers, but divided by 3. So 96 divided by 3, that's going to be 32 pi. 32 pi cubic inches, and then 32 times pi is 100.5 cubic inches. So this problem in example 6 is giving this application of these formulas. So it says you have an ice cream cone. The cone is 5 inches deep and has a radius of 1 inch, and then there's a scoop of ice cream on it, spherical, right? A sphere is just like a ball, right? So a spherical scoop of ice cream on top also has a radius of 1 inch, and this is the formula for volume of a sphere. So we'll use this formula for the volume of the ice cream, and what we're trying to answer is this: if the ice cream melts, will it overflow or will it fit into the cone, based on the cone being 5 inches deep and having a 1 inch radius. So this is what we're going to do, right? We're basically going to take the volume of the, volume of the sphere. Remember, the sphere is the ice cream, right? The volume of the sphere versus the volume of the cone is kind of what we're looking at, right? If the ice cream has a higher volume, it's going to overflow. If the cone has a higher volume, it's going to not overflow. So the volume of the ice cream, remember, it's a sphere, it's like a ball. So use this formula. So it's 4 times pi. The radius is just 1, so that's easy. And then divide by 3. Okay. So 4 times pi divided by 3. Let's see what that is. 4 times pi divided by 3. Remember, 1 cubed is just going to be 1. So the volume of the ice cream is about 4.2 cubic inches. The volume of the cone is, remember the cone formula is pi r squared h divided by 3. So pi times the radius squared, oh whoops, the radius is 1, sorry about that. Pi r squared times the height is 5, divided by 3. So 5 times pi divided by 3, well I think I already know which one's going to be more here. The volume of the cone is 5.2 inches cubed, so, well, according to this, then the cone has more volume, so it will not overflow, right? If the ice cream melts, it will not overflow, right? Again, volume of the ice cream, radius is 1 inch. Volume of the cone, right? Radius is also 1 inch, height is 5. The cone has a higher volume, so it should not overflow. So just to give you a better look at that problem, again, the ice cream cone, as it turns out, it even says it here, the volume of the spherical scoop of ice cream is less than the volume of the cone, so there will be no overflow. This last problem, practice 6, deals with a basketball. It says a basketball has a radius of 4.5 inches. Okay, so, and then it says that it's going to get 350, is this enough to fill it up, is what it's saying. So, again, the basketball's radius is 4.5 inches, and then basically if we put 350 cubic inches of air in the basketball, will it fill it completely? Well, we can calculate the volume of the basketball to, check on this. So it's 4 times pi times the radius is 4.5, radius cubed, and divide by 3. So we'll calculate that out, and basically this, right? If this is more than the volume, then this will definitely fill it up. If this is less than the volume, then this will not fill it up. So let's see. 4 times pi times 4.5 to the 3rd power, and then we'll divide that by 3, and I got the volume of the basketball is 381.7 cubic inches. So the volume of the ball, it's going to get filled with 350 cubic inches of air, so 350 is less, right? So aka it's not quite enough to fill it up. So the ball will not be completely full. Of air, right? So again, it was the volume of the ball, how much air is going in, and it's not quite enough air to fill up the ball. So we'll end it there for today.